Okay, so we talked about some basic rules, like the power rule and things of that nature, but now it's time to get into a new rule for the product of two functions, and that's called the product rule. So we'll start off with just the notation so you can get comfortable with that, and then we'll look at three examples. So basically what the product rule says is anytime you have the product of two distinct functions, to find the derivative of that overall function, you have to do the following. You'll take the derivative, let's say, of f, and you'll multiply that times g, not the derivative of g, just regular old g. And then to that, we will add, and we'll kind of flip it up here, f of x, right, but this time times the derivative of g. So take a step back and kind of look at that for a minute before we do an example. Basically what we did is we took the derivative of one function times the other original function plus, and then we did a swap, the derivative of the other function times the original first function. Sometimes you'll hear me say things like the derivative of the first times the second plus the derivative of the second times the first. So you can think of it that way as well. Let's look at an example. So this is the first example you have in front of you, and what I've done here is I've gone ahead and noted the first function x squared plus 2x minus 5 as f and the other one as g. It does not have to be that way. You can switch them up because it's commutative because of the addition. So what we'll do here is we'll just execute the rule, right? So the derivative of f, right, f prime, would be 2x plus 2. And this will get multiplied, remember like the rule said, times x cubed minus 1. Unchanged, not derived at all. And then what we will do is we will add to that the derivative of this second function. So we'll put that in green here for you. And that is just 3x squared. And we'll multiply that times the original first function of x squared plus 2x minus 5. And the beautiful thing here is you're done. That is the product rule. So a couple things to note as we take a look, right? This piece right here is f prime. And this piece right here is g prime. Okay, but we had to mix and match a little bit to pull off the product rule. Now, could I do more? Technically, you could. And right now, I don't think that that's what we're looking for. But technically, if you were asked, they could ask you to simplify, and you could distribute and combine like terms and all that kind of stuff. Just for what we're doing right now, and I think learning the rule, I think we're good. We'll just leave it like that. Okay, let's look at another example. So again, get more comfortable understanding which function is f and which function is g, or at least seeing the split between the two. So here we go. There's one function and there's another one. Now in this problem I don't like the fact that I have the square root of x. So what I'm going to choose to do here is rewrite that as x to the 1/2, and I'll leave the second function as is. Okay, so the product rule, here we go, the derivative, right? So the derivative of x to the 1/2, well there's my power rule, so 1/2 x to the negative 1/2. Again, all being multiplied times this original g function, so there it is, right? Plus, now I need to take the derivative of this second function, so that's 21x to the 6th plus 8x cubed. And remember, that all gets multiplied by the original first function, which was x to the 1/2. And again, just like the last problem, could I simplify? I could. It's just a little messy, and really I don't know where it would get you, so I don't think there's any reason to do it. So let's do one more. Okay, now in this example, I wanted to point out again some of the things that we can think about. Now, we could have done this in the other examples as well. Somebody might ask, well, why can't I just FOIL here? Why can't I just distribute right away? And you could. I don't know that it would be faster. I mean, you could try it, and there would be some examples where it might be. I think in this example, we certainly don't want to leave it the way it looks now. So again, I'll do some rewriting here. Let's write this as 1 minus, and then 1 over x squared can be rewritten with a negative exponent. So I think that's a little bit better if we do that. And again, what do we have here? We have f right, and g. Okay, so derivative, here we go, right? Derivative of the first function. So the derivative of 1 is 0, and then you have the minus, right? So 0 minus, now look what happens here, x to the negative 2. So it's really negative 2x, reduce the power, negative 3. All that gets multiplied by the original x plus 1. And then plus, right, and here we go, derivative of x plus 1. Well, remember, the derivative of 1x is just 1, and the other 1 here, the plus 1, that drops out. So that's it, simple derivative on that part. And again, we'll leave this as 1 minus x to the negative 2. Now, in this problem, we haven't done it yet, so let's just go ahead and do some simplifying here, because there's a lot of things we could do. So, for instance, this is positive 2x to the negative third times x plus 1. And then this is basically just 1 minus x to the negative 2. So let's just see what happens when I distribute here. I get 2x to the negative 2 plus 2x to the negative 3 plus 1 minus x to the negative 2. And if you look very carefully, you'll see here that there are some like terms, so we might as well combine them, so giving us a final answer of 1x to the negative 2 plus 2x to the negative 3 power plus 1. Okay, so at this point, you'd want to at least kind of get together with your group, see if you have any questions for each other about the video that you just watched here, and then practice your specific product rule problems, and then we'll kind of put it all together with another rule called the quotient rule.